Hi everyone, my name is R. Jagannathan. She is my teammate R. Kalarani. She is my teammate Jennifer Cinderella. And I am today excited to present my project IoT based automatic fish feeder for remote feeding, control and monitoring. Uh, and aquaculture is, and now we move on to my project. Aquaculture is rapidly growing industry that plays a vital role in food production. However, one of the major challenges in fish farming is feeding efficiency. Traditional feeding methods such as mutual feeding or IoT based dispatcher are unreliable. Overfeeding leads to water pollution and food wastage, while underfeeding affects the food growth and fish growth and health. To solve these issues, we have designed a smart IoT based automatic fish feeder which automates the feeding process, ensuring accurate precision control and remote monitoring via smartphone apps. This system not only reduces human invention but also optimize fish feeding for better health, lower cost, and improved farm efficiency. Now we move on to the problem statement of our project. Now let's discuss main challenges that led to development of this project. Inconsistent feeding. Manual feeding depends on human availability, leading to irregular feeding times. Overfeeding and water pollution. Excess food decompose in the water, increasing ammonia level, which is harmful to fish. Underfeeding and malnutrition. When fish do not receive accurate food, their growth rate decreases, leading to lower productivity. High labor dependency. Farmers must be physical present to feed this fish, making it inconvenient for large-scale operations. Lack of remote monitoring. Traditional feeders do not provide real-time updates on the food level or feeding activities. Um, our IoT-based fish feeder overcomes these limitations by providing automatic scheduled feeding with real-time monitoring and ensuring optimal fish health and farm efficiency.
Existing system was proposed the system. Existing system, several fish feeding method exist, but each has drawbacks. First, manual feeding, simple but time consuming. Inaccurate portions control leads to waste or malnutrition, and then requires constant human presence. Next, timer based feeders can automate feeding but lack of flexibility. Fixed portion size cannot be adjusted dynamically. No real time monitoring of food levels. RFID based feeder. User RFID chips to feed fish selectively, costly and difficult to implement on large scales. And then next, proposed IoT based system. IoT based system. The system integrates IoT technology with a microcontroller, a DC motor, and a mobile app to provide automated feeding. Feeds fish at scheduled times. Remote control. User can adjust feeding, scheduling, and portion size for anywhere. Real-time monitoring tracks food levels and notifies the user when refilling is needed. Energy efficiencies, lower power consumptions, making it as a cost-effectively. This smart feeder enhances profitability, reduce the labor, and ensure the healthier fish. Next one is design and components. Like now, look at the hardware and software components that make this system works. First of all, hardware components. ESP8266 microcontroller connects to Wi-Fi and control the feeding mechanisms, and then DC motor rotate the dispense the exact amount of fish food, and then ultrasonic sensor measure the food level in the container and alert the user when it is low. Relay and model control the motor on-off switchings, power supply, A5V adapter on battery to power the systems. Next, components. Embedded C used to program to ESP8266. Blink IoT platforms provides the mobile application interface for remote control and monitoring. Wi-Fi communications allow the feeder to be controlled from anywhere. We see about the working process. The ESP8266 connects to the Wi-Fi and syncs with the Blink app. At the scheduled intervals, the microcontroller active to the server motor with the dispense food. Then ultrasonic sensor checks the food levels and send the real-time alerts if it is low. User can manual override feeding using the mobile apps. The systems ensure precision, efficiency, and automations in the fishing field.
Implementation and testing. After assembling the hardware and programming the software, we tested the system for feeding accuracy. The feeder consistently dispensed pre-measured portions with 95% accuracy. Ensure that fish receive the right amount of food each time. Response time. Remote commands from the app were executed within 150 milliseconds. The system responded instantly, ensuring reliable feeding. Wi-Fi connectivity. The system maintains stable connectivity up to 30 meters indoors and 50 meters outdoors. Power consumption. The system operated efficiently on 2.5 watts, making it energy saving. User interface and alerts. The Blink app provides an easy-to-use interface. Real-time alerts for low food levels and successfully feeding were tested successfully. These tests provides the system is accurate, reliable, and user-friendly. Future enhancement. While our system is effective, future improvements could make it even more advanced. AI-based adaptive feeding, the system could analyze the fish behavior and adjust portion size dynamically. Water quality monitoring, adding pH temperature and oxygen sensors to ensure an optimal environment. Multi-feeder synchronization, controlling multiple feeders from a single app for a large-scale farms. Battery backup, ensuring uninterrupted feeding during power outages. Image processing for food level detection, replacing the ultrasonic sensor with a camera-based system for more accurate food level detection. These enhancements could make the IoT fish feeder even smarter and more efficient. Conclusion. To summarize, a smart IoT-based automatic fish feeder provides automated and precise feeding, reduce human efforts and ensuring consistency, remote monitoring and control, accessible from anywhere via a mobile app, real-time alerts, preventing food shortages and optimizing feeding schedules, cost effectiveness and energy efficiency, making it practical solution for both small and large-scale fish farms. This project represents a step towards smarter and more sustainable aquaculture, benefiting fish farmers, pet owners, and the environment. Thank you for your time.
Let's see our project model. This is power step down transformer. These two are used to reduce the voltage of the power supply. Then this is the microcontroller and Wi-Fi model. This microcontroller acts as the CPU and control every other device, and the Wi-Fi model is used to connect with the mobile phone. Then next, this is a relay module. It used to control the motor, like turn it on or off. Then this is a motor. The motor rotates to dispense the exact amount of the food. This is our project model.